Most planets can exist for a long, long time, but they can't last forever. Hungry stars and violent planetary neighbors can completely destroy a world, while impacts and excessive volcanism can render a habitable world sterile by stripping the planet of its water. Planets die all the time right in our galactic neighborhood. Some are smashed to pieces by massive collisions with other planets. Some are torn to pieces then tossed onto their stars. Some are swallowed by their stars when the star runs out of hydrogen fuel in its core and puffs up to become a red giant. Life is more fragile than planets. Planets can lose the ability to host life without being destroyed. Some planets' oceans evaporate into space. Planets' atmospheres are blown away by radiation from their stars or nearby supernova explosions. Planets undergo such strong tidal heating that their surfaces turn into oceans of lava. Planets freeze over into ice balls that never melt. And on some planets life is stunted or wiped out by bombardment of asteroids and comets. Yet planets can maintain life in places we didn't think possible. On planets covered in dense atmospheres on much colder orbits than Earth. On moons that orbit gas giant planets and are heated by tidally driven volcanoes, sort of like Pandora. Even on rogue planets that are not bound to any star but wander the galaxy. And some planets never die. They retain habitable conditions for 10 times longer than the current age of the universe. I think of them as spooky, zombie elf worlds. There are different ways to define a planet's death. Destruction. For example, when a planet falls onto a star, there is no more planet left. Sterilization. For instance, when a planet loses its atmosphere and water, life as we know it is out of luck. Mass extinction. This can come from a dramatic change in conditions. For example, when a planet freezes over it, any species that can't handle cold will die off. Planetary life will not be wiped out as long as some species can handle the new conditions. Destruction, sterilization, and mass extinction. 3 ways to die. But very different outcomes for the planets themselves. How does Earth's story fit in? Our planet has undergone several mass extinctions. The most famous was the asteroid that hit the Earth and killed the dinosaurs 65 million years ago. Within the next billion years, Earth will be sterilized. The warming sun will boil away our oceans. That will be Earth's sterilization. In 5 billion years or so the sun will swell into a red giant the size of Earth's orbit. Mercury and Venus will be engulfed. Earth may be pushed outward or eaten up. When the sun shrinks down into a white dwarf a few 100 million years later, the spectral signature of debris raining down will be the last glimpse of life on Earth. The most common weapons for planet assassination are pretty common: gravity and radiation. And remember, our situation is unusual. Most planetary systems are very different than our solar system. The sun is rare. Most stars aren't yellow, they're red. Most potentially life-bearing planets orbit red dwarf stars, because they represent 3/4 of all stars. Red dwarf stars are small and faint, and their habitable zones are much closer in than Earth's orbit around the sun. That means that some effects will be much stronger on these planets, like tides. Climate catastrophe. Earth's climate cycle plays an important role in making sure the planet is neither too hot nor too cold to sustain life. But it doesn't take much for the climate on a rocky world such as Earth to get thrown out of whack, triggering events leading to either an incredibly hot planet or a snowball world. On Earth, the temperature is regulated by the amount of carbon dioxide in the atmosphere. Carbon dioxide and other greenhouse gases in the atmosphere, such as water, methane and nitrous oxide, act as a blanket, keeping the planet warm by slowing down how much of the sun's radiation escapes back out into space. When carbon dioxide builds up in the atmosphere, it warms the surface of the planet, causing it to rain more. Rainfall then removes some of the carbon dioxide from the atmosphere and deposits it in the carbonate rocks on the seafloor, and the planet begins to cool. If carbon dioxide accumulates in the atmosphere faster than it can be reabsorbed into the rocks, because of something like increased volcanic activity, for example, it can trigger a runaway greenhouse effect. Temperatures can rise above the boiling point of water, which can be a problem for sustaining life, seeing as all life as we know it requires water. Rising temperatures can also allow the atmosphere to escape into space, removing the protective shield that deflects radiation from a planet's sun and other stars. Greenhouse heating is a fact of life for an atmosphere, and desirable to some degree. But things can get out of hand. Heat isn't the only way climate can turn deadly. When a planet gets cold enough, that body turns into a snowball world, a rocky object covered in ice. Ice and snow are bright and reflect much of a star's heat back into space, causing the world to cool down even further. On a world with surface volcanoes, eruptions can dump carbon dioxide and other gases back into the atmosphere, heating the world back up. But if the snowball conditions occur on a planet that lacks plate tectonics, and therefore, volcanoes, the world may be permanently locked in a snowball state. All potentially life-bearing planets run the risk of climate catastrophe, which can render a planet uninhabitable but not destroy it completely. Lava or life on the planet. The tug of neighboring worlds can pull on a planet's orbit, which puts pressure on the planet's interior and increases the heat of the Earth's middle layer, the mantle. That heat must find a way to escape, and the most typical method is through a volcano. Volcanic activity can significantly affect the environment of a planet. According to the University Corporation for Atmospheric Research, gas and dust particles thrown into the atmosphere by a volcano can affect a planet's atmosphere, cooling the planet and shading it from incoming radiation. In 1815, the eruption of Mount Tambora, the largest eruption in Earth's recorded history, threw up so much ash that it lowered global temperatures, making 1816 the so-called year without a summer. Volcanoes can also cause the opposite effect, global warming, as they release greenhouse gases into the atmosphere. Frequent and large volcanic eruptions could trigger a runaway greenhouse effect that would turn a habitable world like Earth into something more like Venus. Today, Earth is constantly accumulating about 100 tons of interplanetary material each day in the form of dust. Objects larger than about 330 feet crash down to the surface only about once every 10,000 years, while bodies larger than 2/3 of a mile, 1 kilometer, crash down only once every several 100,000 years, according to NASA's Center for Near-Earth Object Studies. When giant planets are tossing these destructive crumbs toward the sun, collisions spike, and impacts happen more often. Medium-sized objects can toss up dust and debris into the atmosphere, which can interfere with atmospheric processes. Giant impacts can cause even more dire effects, not only because of the devastation at ground zero, but also because they may throw up enough debris to cause an impact winter, throwing the planet into a mini ice age. With enough impacts fired off in a row, the climate effects could build on one another until they eventually rendered the world uninhabitable. Based on observations of the planetary leftovers found around other stars, that about 1 billion Earth-like planets in the galaxy will eventually be destroyed by a bombardment of asteroids.